Solve the differential equation in two different ways. First, by using the theory of separable equations, and then using the theory of linear equations. So first we'll do separable, and to do separable, let's expand this a little bit. We're going to have our y prime be represented as dy over dx, and this is equal to x minus xy. Now we need to separate this. So what we're going to do is bring the y to the other side. And to do this, we're just going to factor out our x. So we'll have a dy over dx is equal to x, where we have 1 minus y inside of here. Now we can divide both sides by 1 minus y and dx. So we'll have 1 over 1 minus y dy is equal to a x dx. Now from here, we can take the integral of both sides. Since we don't have any bounds, we'll have to have a plus c on the right. And from here, we are going to get an ln of 1 minus y. Since we have a negative in front of our y, we have to have a negative out front. If you don't know how to do that, basically if you have anything in the denominator right here, you can u sub it, and it'll get you to this as well. Or you can just know that if you have something like this, you put it in ln, and then whatever's in front of the y, you're going to put it outside. And this is going to be equal to our x squared over 2 plus c. Now we want an equation for y, right? So we're going to have to raise everything to the power of e. And in doing this, we are going to get, well, first of this negative right here, we can move it over to the other side, so we don't have to deal with it, and we just have a clean e to the ln cancellation right here. It's going to give us a 1 minus y is equal to a negative x squared over 2, and then we'll also have minus c. Now we can rewrite this as e raised to negative x squared over 2 times e raised to negative c. And notice how this is just completely a constant right here. We can then again write this out as a constant times a e raised to negative x squared over 2. And the negative doesn't really matter for this, since it's a constant, it's just going to be a constant. So when we rewrite this fully, it's going to look something like this. 1 minus y is equal to c e negative x squared over 2. But since we want an equation for it, we're going to solve for y, and we're going to put y on the other side. And we'll say we have y is equal to a 1 minus a c e raised to negative x squared over 2. Or you could just say it's a plus because it's a constant. So plus or minus, I believe either or is correct. So that is going to be how we would look at this. And that is for our separable equations. Now, we also want to look at the theory of linear equations. And for our theory of linear equations, we are going to rewrite this like how we rewrote it for separable equations, dy dx. But we want to move our negative xy to the other side. So it's going to become a plus xy is equal to x. And this is because we want to assign our px and qx values. So this right here is going to be px, and this right here is going to be qx. Now that we have those, we are going to want to move on to the next step, which is to find the integrating factor. And to find the integrating factor, we're going to have I of x be equal to e be raised to the integral of px dx. Now the px isn't this whole thing. Notice how I put like a little bracket on this whole part right here, a little brace. Well, it represents this whole thing. That's how you would find your px. So your px is found by this part, but the p value itself is only this x. So inside of here, this is just going to be an x. And so what that means is we're just going to take the integral of x, and the integral of x is x squared over 2. So we're going to have e raised to x squared over 2. Hopefully that makes sense. It's a little bit confusing. You just need to determine which values are the px and qx. And then for our px, it's going to be whatever value is the x. So not the y. The y is just going to act like a constant that we don't look at. Next, we want to use the integrating formula. And the integrating formula says that y is equal to 1 over our ix. And then this is being multiplied by the integral of our ix. Then we'll have our qx, then we have our dx, and lastly plus c is going to be inside of here. So to do this, our integrating factor is plugged in. It's going to be e, or 1 over e x squared over 2, or you can just write it as e raised to the negative x squared over 2. So we can flip the signage. And then inside of here is where we have our integration. So let's plug in for this right here. We have the integral of our I of x, and our I of x is just going to be e x squared over 2. Our qx is just going to be x, and then we have dx. So what we can do here is a u sub. Notice that if we u sub for our x squared over 2, we'll have a du equal to a x dx. So when we plug this back into here, we're going to have e raised to u du. And then when we integrate this, it's simply just going to be an e raised to u. And so inside of here, we can just plug in e raised to u, which is x squared over 2, and then we of course need our plus c. Now from here, we're going to want to distribute this in here and here. So we're going to get that y is equal to, if we distribute it into the first one, we basically have it divided by itself, so it's going to give us a 1, and then we'll have a plus c over an e x squared over 2. And you can see that's going to be the same result as if we did it with our separable equation. So that's just two different ways of doing it.